July 1969, Apollo 11 achieved one of humanity's that keeps the legacy of Apollo alive. The moon landing sites are invaluable historical and scientific markers. They offer a unique snapshot of a past era of exploration and provide ongoing data for future missions. The Apollo missions left equipment, footprints, and evidence of human interaction with the lunar surface. This legacy is a critical starting point for modern lunar science. Studying these old sites is vital for planning new missions, especially those involving long-term habitation. We learn about material degradation, surface stability, and contamination risks. One of the key tools for modern study is NASA's Lunar Reconnaissance Orbiter, or LRO, which has been observing the moon since 2009. LRO uses high-resolution cameras to capture incredibly detailed images of the landing zones, essentially giving us eyes on the ground from orbit. These images reveal clear visual evidence: astronaut tracks, discarded hardware, and the telltale disturbed soil left by the descent engines of the lunar modules, all still intact decades later. While remote sensing is powerful, the analysis of the Apollo samples brought back to Earth remains crucial for deeper insights. Decades after their collection, scientists continue to study these preserved lunar rocks and soil using advanced analytical techniques that weren't available back then. New technologies are revealing detailed insights into the moon's geological composition, volatile elements, and the ancient environmental conditions preserved within the samples. A major focus of studying the sites is understanding how the lunar environment affects materials over time, particularly lunar dust and space weathering effects. Scientists are examining the degradation of hardware and surface materials caused by constant bombardment from micrometeorites, solar radiation, and extreme temperature swings. This degradation data is crucial for materials science, helping engineers design durable equipment and habitats for a sustained, long-term human presence on the moon. The Apollo landing sites are more than scientific testbeds. They are protected historical landmarks that need careful preservation. LRO's detailed mapping helps identify and catalog the location of every human artifact on the lunar surface, ensuring these pieces of history are monitored and respected. Future missions near these sites are guided by planetary protection guidelines to prevent contamination and damage, safeguarding these historical and scientific treasures for generations. The work of studying the old moon landing sites is far from over. It represents an ongoing commitment to scientific discovery and historical preservation. The data collected decades ago, combined with modern observations and analysis, directly informs the next steps in human lunar exploration, from Artemis and beyond. As we prepare to return to the moon, these historical sites remind us of what's possible and provide the scientific foundation for humanity's continued journey into space. Welcome! We're diving into the legendary Apollo 11 mission. But beyond the history books, the moon landing continues to spark viral conspiracy claims. We're here to set the record straight. In July 1969, Apollo 11 achieved one of humanity's greatest feats, landing humans on the moon. This mission represented an incredible leap in technology and human determination. The moon landing captivated the world, proving that with enough effort, the impossible is achievable. Yet, the very scale of this achievement has led to decades of skepticism and viral theories. Why do these claims persist? They often focus on perceived visual anomalies in photographs and video. We'll tackle the most common ones that keep circulating online. The American flag planted on the moon is perhaps the most debated piece of evidence. People often point to its appearance as proof of a staged environment. The main claim is, how can the flag appear to wave in the vacuum of space where there is no wind? This seems like a contradiction to the laws of physics. The reality is simple. The waving look is due to a rigid horizontal pole designed to keep the flag extended. The creases and wrinkles are from being folded during transport, not from wind. Another frequent claim involves the absence of stars in many of the famous Apollo photographs. This leads many to believe the pictures were taken on a soundstage. The specific conspiracy asserts, if the photos were taken in space, why aren't any stars visible in the pitch-black sky? This is a simple photography issue. The moon's surface, illuminated by the bright sun, required short exposure times. Stars are too dim to register on the film during such short exposures. The next viral theory suggests that identical backgrounds in different photos prove the use of a limited set or backdrop here on Earth. The claim states, footprints or objects in different images appear to have identical backgrounds, suggesting a repeated fake set. The moon is a vast, static, and barren landscape. Distant features look the same because they are incredibly far away and don't change. Many images are also parts of planned panoramic shots. One peculiar claim focuses on a photograph where a rock appears to have the letter C written on it, suggesting it's a labeled film prop. The specific assertion is, a rock in one photo is clearly marked with a C, proving the lunar surface was actually a studio set using props. Experts believe the C is most likely a stray hair or fiber accidentally included during the photo processing, or an anomaly in the reproduction of the image. We've examined the most popular claims. All of them have logical, scientific, or photographic explanations that fully align with the successful Apollo 11 mission. Beyond debunking visual claims, hundreds of pounds of lunar rock samples, left behind equipment, and independent satellite imagery from other nations confirm that humans did indeed land on the moon. The takeaway? When you see sensational viral content, remember to pause, research the facts, and trust overwhelming scientific consensus over dramatic From the giant leaps of Apollo to the ambitious missions of Chandrayaan, humanity's quest to explore the moon continues. Join us as we explore the enduring legacy of Apollo 11 and its influence on India's Chandrayaan missions. The Apollo 11 mission in 1969 wasn't just a win for the U.S., it was a defining moment for all of humankind, fundamentally shifting how we viewed our place in the cosmos and setting the stage for future global endeavors. We remember the historic journey of Neil Armstrong, Buzz Aldrin, and Michael Collins. Apollo 11 showed the world that with collective will, the seemingly impossible could be achieved. Apollo 11's success fueled imaginations and inspired nations worldwide to embark on their own journeys of space exploration, including the ambitious space program of India. Fast forward to the 21st century, and India's Chandrayaan program emerges as a testament to this global inspiration, marking India's powerful entry into lunar exploration. The Indian Space Research Organization, or ISRO, has demonstrated remarkable capability, pursuing lunar missions with innovation and precision, aiming to uncover new scientific knowledge about the moon. Chandrayaan-1, launched in 2008, was India's inaugural lunar mission. It successfully orbited the moon and, most notably, confirmed the presence of water molecules on the lunar surface, a crucial discovery. Chandrayaan-2 followed, aiming for a soft landing near the moon's south pole. While the orbiter performed flawlessly, the Vikram lander faced a challenge during its final descent. The mission was ambitious, including the deployment of the Pragyan rover to study the lunar surface composition, seismic activity, and search for water ice. The setback with the Vikram lander was met not with defeat, but with determination. The lessons learned were invaluable, laying the foundation for an even more rigorous and ultimately successful follow-up mission. With renewed focus and engineering excellence, Chandrayaan-3 launched, carrying the hopes of a nation for a soft landing on the moon's south pole. In August 2023, India achieved the historic feat, becoming the fourth country to successfully execute a soft landing on the moon and the first to do so near the mysterious lunar South Pole. The South Pole is a scientifically rich region, believed to harbor significant amounts of water ice in permanently shadowed craters. This resource is vital for future sustained lunar bases and deep space missions. The achievements of Apollo 11 and Chandrayaan missions are separated by decades, yet they share a common thread: the spirit of exploration and the drive to push human limits. Apollo's footprints laid the groundwork, inspiring generations of scientists and engineers, many of whom contributed to India's monumental lunar success. India's Chandrayaan success firmly establishes the nation as a key player in the next era of space exploration, driving international collaboration and innovation. We are now witnessing a new space race, driven by scientific curiosity and the potential of lunar resources. Future success relies on global partnership, echoing the universal impact of Apollo 11 and embracing the new breakthroughs of missions like Chandrayaan. To see how the legacy continues, follow the Artemis program, aiming to land the next humans on the moon and establish a long-term presence. The moon. Welcome. We're diving deep into the stunning images sent back by India's Chandrayaan-2 mission. This video will explain the facts and help you distinguish them from the rumors. Chandrayaan-2 was India's second lunar exploration mission, launched by the Indian Space Research Organization, or ISRO. It was a hugely ambitious endeavor. The mission aimed to study the moon's topography, mineralogy, elemental abundance, and the lunar exosphere. It included an orbiter, a lander, and a rover. The images captured by the Chandrayaan-2 orbiter are vital. They provide unprecedented data about the moon's surface, helping scientists understand its origin and evolution. Let's focus on the facts. The images confirm the presence of certain minerals and show detailed thermal and physical characteristics of the lunar surface, particularly the polar region. All authentic Chandrayaan-2 images are released directly by ISRO. Always verify images against ISRO's official website and press releases to ensure accuracy. A major discovery from the images includes high-resolution mapping of the lunar surface. They also provided data on water ice in the permanently shadowed areas of the moon. Unfortunately, every high-profile space mission attracts misinformation. We've seen various fabricated images and exaggerated claims circulating online. False claims often suggest images show alien structures or unrelated historical artifacts. These are generally digitally manipulated images or misattributed photos from other missions. To spot unreliable information, always check the source. If it's not a credible space agency or verified scientific journal, be skeptical. Look for image resolution discrepancies too. In conclusion, Chandrayaan-2 has delivered invaluable scientific data through its images, significantly contributing to our understanding of the moon. Stick to the facts. The mission was a success, providing the highest resolution data to date for parts of the moon. Its findings help prepare for future lunar and deep space missions. For the latest confirmed facts and images, visit ISRO's official website and their social media channels. Don't let rumors cloud the brilliance. 55 years ago, humanity achieved the impossible with the Apollo 11 mission. But what does that historic landing site look like today, through the eyes of modern spacecraft? Welcome to a look back at Apollo 11, and forward to the incredible high-resolution views new lunar missions can provide of this monumental site. The Apollo 11 mission, culminating in the 1969 landing, marked our first steps on another celestial body at a location known as Tranquility Base. Today, orbiters like NASA's Lunar Reconnaissance Orbiter, or LRO, provide unprecedented high-resolution imagery, allowing us to spot artifacts left behind with stunning clarity. The Apollo 11 landing site, Tranquility Base, remains largely preserved in the vacuum of space. Let's see what features are still visible after decades. From orbit, the high-resolution cameras can map the entire area, detecting subtle changes and providing context to the historical operations conducted there. One of the most prominent features visible is the descent stage of the lunar module, Eagle, the base unit left on the surface when the ascent stage lifted off. Perhaps most fascinating are the faint but distinct traces of the astronauts themselves, immortalized in the lunar dust. The LRO has captured images clearly showing the boot prints of Neil Armstrong and Buzz Aldrin, as well as the paths they walked during their extravehicular activity. We can also identify the tracks left by the deployment of scientific equipment, which were moved short distances from the landing site. Apollo 11 left behind crucial scientific instruments that continue to operate, or at least whose remains are detectable from orbit. The Lunar Laser Ranging Retroreflector, or LRRR, is a passive device still used today to precisely measure the distance between the Earth and the Moon. Another significant item is the Passive Seismic Experiment Package, or PSEP, which transmitted data on moonquakes for a short period after deployment. Beyond scientific instruments, the site is also home to everyday items deemed unnecessary for the return trip. New missions can image discarded survival gear, including backpacks and tools, which were intentionally left behind to reduce weight for the ascent stage launch. The location of the iconic American flag is also identifiable, though high-resolution imagery suggests the nylon fabric has likely disintegrated or fallen due to solar radiation. In conclusion, modern lunar missions offer a unique perspective, bridging the past and present of space exploration. This high-resolution data helps historians verify records, and scientists study the long-term effects of the lunar environment on human artifacts. As we look to the Artemis program and future missions, these historical sites will remain crucial points of interest for scientific and cultural preservation.